Hello, this is Glenn Danes. I'm a professor of Material Science and Engineering at Ohio State University. I'm also affiliated with the ASM Materials Education Foundation and the National Network of Manufacturing Innovation Center, Lightweight Innovations for Tomorrow, which is called LIFT also. And I'm going to try to get my pen to work. Just a second, bear with me. Without my pen, I feel I can't do much. And what I'm going to do is introduce a small series of videos to you about materials in automobiles and lightweighting. Just want to set context behind these things, and I'm going to try to keep all of these videos very short and connect other content to them. So with that, here's the essential problem. What do we really want from a vehicle? We want it to be safe, quiet, durable, efficient, perform well. Means it doesn't have sufficient. It doesn't have too much body roll, things like that. The frame should be stiff and all that, and that adds to good performance. And we also like it to be efficient. And we'll get into efficient later. That really means that the vehicle itself should be very lightweight. You should also have a very efficient powertrain. In this little series of videos, I'm going to talk about how we use materials to make vehicles that are safe, durable, and quiet, and how that turns into materials properties in a little bit. And then later, in later bits of this, we'll talk a little bit more about manufacturing and lightweighting and those kinds of things in more detail. So this is pretty much the way all vehicles are made today. This is a Volkswagen example. Basically what you do is you take steel. All of these are sheet steel. For each sheet, it has a given thickness. You also have different material properties depending on which steel you pick. You might end up having higher strength steels here than out here for reasons that'll be clear in a little bit. But regardless, you take that sheet steel, which is a rolled product, and we put that into a stamping press, and stamping makes these shapes. A stamping press works like this. We basically take our flat sheet metal, put it into a die ring, clamp it around the edges, a punch and die comes through, and basically squeezes this material to make all of these shapes that you end up seeing here, and then you trim the edges, and you're ready to take those parts and assemble them together to make this overall vehicle structure, this assembly. So the way we end up assembling them, once you make the individual parts, we end up putting them together by a process called resistance spot welding, which is shown here. We basically take two electrodes, squeeze the materials we want to join together with a force, run a large current through that, and that ends up melting a little region of the steel between these things, and that after that solidifies, you end up with a nice steel structure that's all held together. And this is done robotically, where the parts come together. Robots do the welding. You see robotic welding down here, and then these are the actual welds you'd see if you look at a location, something like this. You'd see welds that look like that. That's what holds it together. That's pretty much the way all vehicles are made. 99% of vehicles in the United States are made by the technology just like this. This is what we call a unibody. It's very efficient, very safe, and most importantly, it's very economical to produce to get very high performance structures. One of the biggest things we want out of this is we would like something that's safe. And we're going to show a couple examples. We're going to focus on the Malibu, nice General Motors product, a fairly inexpensive car. Still with a lot of great engineering in it, and we choose this simply because there's great content available. Let me show a compilation of what the Malibu does and how it does it. So you can see we smash it, and the important thing you're seeing here is the area where the passenger sits is hardly getting crushed at all. You sacrifice the front and the back to give it a little bit of cushion, but the area where the passenger sits, you want that to be a safety cage. You don't want that to deform, and in this vehicle, GM does a great job of that. You can see the front and back absorb energy, but the center of it hardly deforms no matter what you do. When we talk about lightweighting, we often have this idea that, and let me get back to my content here. We often have this idea that big old cars would be safer than the newer, smaller cars. That's really not the case. Here's an example of a 1959 Bel Air going up against a 2008 Malibu. And you can see exactly what I was talking about shouldn't happen happens. This passenger compartment is deforming tremendously. The poor guy in there is having a really, really bad day. As you'll see in a little bit, the dashboard just came up into his face. You do not want to be in that 1959 Bel Air despite its mass in a collision. If you look at the Malibu, the 2008 or 9 vehicle, the front end deforms, cushions it, and the passenger safety cage is just about non-deformed. It performs very, very well. Again, here's the inside of the Malibu. Watch the dashboard come up, crush the poor dummy. His legs have probably been sacrificed in that, whereas if you look at the Malibu, the safety cage is intact. It's still a violent collision, but this dummy can go on and live another day. So these improvements in engineering have saved many, many lives, and this is why engineers are such wonderful people in many ways. They do save loads of lives this way. So anyway, that's safety, and it all comes from materials properties. Another thing you'd like is quiet. You can look at these two possible things that may or may not be a vehicle, and which one would be quieter? Well, probably this one, simply because it's got way, way thicker than this one. If you bang on the side of this one, nobody would care. If you bang on the side of this one, it's going to bang like a drum. And this is why things like low-density materials, materials that damp, plastics, for example, do a good job of damping, keep things quiet. So if you want a quiet vehicle, you want to construct it more like the brick house than this one. Again, that happens by having materials that damp, and just having a lot of material usually helps you keep the noise out. Other things like shape matters too. Actually, these corrugations are better than having something that just has flat sides on it, and we can talk about those things later. Durable is another thing. You want your car to last a long time. Here's an example of a water pump. This is what corrosion can do. This is what's supposed to pump the water. If it corrodes away, it goes. And then fatigue is another thing. As things go through repeated loads, you might have fatigue. There's a famous Aloha airline crash about 1979. Fatigue cracks created a convertible 737. Not a good thing. Again, these are material properties that we can engineer. This is important stuff. So what's going on these days? There's actually a time of great change right now. Ford has developed a product that's caught a lot of attention. This is the all-aluminum F-150 that started in 2015. Saves about 700 pounds over the steel version because aluminum has a lower density than steel. It's been a great success so far. It costs a little more. It's a little difficult to make the aluminum vehicle, but it works really well. Here's a Lamborghini design where they go a step further. If you've got an extra $300,000 or $400,000, you can buy yourself one of these. But this has carbon fiber construction through this carbon fiber epoxy construction. We can talk about these composites later. Saves a lot of weight. Could be actually a fairly quiet, sound-absorbing structure, but that's not the way they do it, particularly because the engine sits back here behind the passengers, and you want that engine noise if you've got a Lamborghini. But again, these things are coming, and this is actually going to bring a whole lot of new jobs associated with it, because you're going to need different skills to repair aluminum vehicles and carbon fiber vehicles than the old steel vehicles. So there's a lot of re-education, retooling, and so forth that has to follow along with this. So this is really more where the future is multi-material. This is a vehicle that Volkswagen builds. Again, you can see you've got all kinds of materials, and again, the big concept is you want the safety capsule to be intact, and then you put materials out here, steel to absorb energy front and back, and you engineer that in such a way that absorbs energy in a controlled way, and that keeps people safe. So this is really where we see materials going with vehicles, is using multi-materials, multi-processes, die castings of magnesium, strut towers made out of aluminum, possibly aluminum and steel. All of these things coming together makes for issues with how do you join these. You can't necessarily spot weld anymore. Corrosion might be an issue. Durability can be an issue. And a whole lot of new skills are going to be required. And that's really one of the big motivators for everything we're doing here. So in conclusion, what do we need? We need components that are strong, stiff. Those in the front and back have to absorb energy. They all have to be durable. And we like them to be light because that makes things that are efficient. Well, how do we get this? First of all, we need materials with great properties. We need low weight, maybe density. We need high stiffness, we need high strength, and then shape is really important. For example, if you take two boards, walk on one, tilt up this way versus that way, get a lot more stiffness out of this shape. I-beams give you a good combination of shape and low weight, or high stiffness and low weight. And you also want things to be low cost. So processes like this to put the material together to give you low cost with these interesting shapes. This I-beam rolling is an important technical development. So that's it for now. Other videos will go into further details on this, and this is our basic introduction. Thanks. Feel free to ask me questions if you have any. Take care. Bye.